Hello, my name is Anurag and today I'm going to work on fifth experiment of a System Software and Compiler Lab. So the name of the experiment is simulation of deterministic finite automata, and the aim of the experiment is to simulate the concept for DFA. So let's go on to the description. What is a DFA? DFA is also known as the deterministic finite state machine, which is basically giving out the finite deterministic way of any deterministic way of any finite machine. Okay. So for this, we are the definition of DFA goes as Q, which is will be the set of a finite set of states. The S will be the finite set of input symbols, and the transition will go from will be defined on a D, and the initial or a state or the start state will be defined as Q naught, and the state accepted states would be defined as F. So the algorithm of the program. So initially, first we are reading the number of states. Then after that, we are providing a deterministic a path for the first state, which would be using 0 or 1 or A or B. So after that, the final state is also required, and we go to the next state, give all the description for the other states, and we ask if it is finished or not. And if we are all finished, then we have to also give if that state if that particular state is final or not. And after that, we have to give the input string which can be accepted or which can be accepted or not, and we have to check regarding the theoretical theoretical diagram of the machine. Okay, so this would be the program. Let's not jump to the program first. So first I need to clear you all of this thing. We have I have used inside the program. I have only used the numbers. So input states will always be given as 0 or 1, which you can also say it as A or B, and the states are always defined as 0, 1, 2, 3, and so on. So we can also give it as uppercase of A, B, C, D, and all. Okay, let's go, because it was very difficult to make with the character set. So inside the program, so what we have done, we are constructing each and every node. So the node can be defined, can we say it as this is the definition of a state, and we have used the pointer concept to link each and every state. Okay, uh, this is the maximum size of the array. That means we can accommodate 100 states and as 10. Okay, then let's move on to the next part. So like the algorithm goes, first we are asking the number of states on the machine, and moving forward to the definition of the machine. Then towards the last, we are also displaying the how which all states has been visited, and how many states are visited. And we are also um, after taking the input string, we are also displaying the output as if the string is accepted by the machine or it is not accepted. So let's move on to the working of the program. So enter the number of states of the machine. So here there are I will go by the table. So enter the number of states of the machine. I will give it as 4, and for the state machine 0, that means state 0, or I can, or for other language we can say it as uppercase of A. If the input state is zero, that means if the input state is 0, we will go to 1. Here the input state of 0 can also be stated as lowercase of a. So it will go to the state number 1. Okay, so moving on to the next input, it will ask for if the input state is 1. That means if the input state is lowercase of b, it will stay in that state itself. That means it's a loop. So it will go to the 0 itself. So I have given as 0. Okay, yeah. So it is also asking, so after that the program is asking if this is the final state or not. So we are not giving a state 0 as the final state, so we will give input as 0. And for the state machine 1, now we have to give the definition. Now it will go on and I will just fill in the details. For the input of 1 of the state of the state 1, we are giving as 2. For if this is the final state, no it is, no it is not. So moving on to the state 2 here. So for the first input, it is going to state 1, and for the second input it is going to the state 3. So is this the final state? No, it is not. So moving on to the next state description. So the first input would be 0 and it will go to the state 1, and for the next input which is 1, it will go to the state 0, that is the first state. So is this the final state? Yeah, we want the third state to be the final state, so we will give it as 1. So enter the initial state of the machine. So from the beginning, we have not even set any initial state of the machine. So we will give the initial state as 0 by default. Okay. So now it is asking to perform the string check. So the string can, if we are taking as the character input, the string would be A and B and BB. Like I already said earlier. So now for this we are working on the numbers, a number set. So we will be giving it as 0011. 0011. Sorry, perform string check. First, it is asking if we have to perform string check or not. Yes, we have to perform. So we will press 1, enter the string of inputs. Here we will give it as 0011. Okay, the visited states of the machine. So output we have already got it, and the visited states of the machine are 0, 1, 1, and 2. The present state, which is 3, which is the final state, and the output state is, it is given as string, is accepted. If I want to check another string, yes, I would want it. And this time I will give it as 1100. Let's see it will go or not. So the string is not accept. See, because in the initial state itself, if I am going, then it will go as check, it will go to the state 0, and so after that the towards the end of the machine it will not get accepted. So the states visited which are 0, 0, 0 and 1. So present state which is 1, and 1 is not the final state, so the string is not accepted here. So if I want to check another string, no, I would not want to, and I will terminate the program. So we get out of the program. So this should be the last of it. Thank you.